Hello and welcome to this third in a series of tutorials intended for citizen scientist amateurs that show how to use satellite images to monitor changes in vegetation extent and condition. In this tutorial, we prepared the Landsat images we downloaded in the previous tutorial for processing by QGIS. Before we get started, here are the other tutorials in this series. Check the description below for links to these tutorials. Our last tutorial left off with a folder containing 6 downloaded Landsat images. We will now prepare these images for processing by follow-on tutorials. Here are the steps for preparing our images, starting with creation of a QGIS project with image groups and support maps. As described in the previous tutorial, here is a rationalized folder structure for keeping track of the images we will be working with, which should be mirrored in your QGIS project. Note the addition of support maps that can help you get oriented as we move along. Once the QGIS project is set up, the images downloaded in the previous tutorial can be loaded into the project. Here are the 6 downloaded images loaded into QGIS. With the images loaded into the appropriate QGIS group, you can see the region covered by the images. Here is a close-up of a section of the Band 5 image showing the individual 30 meter by 30 meter pixels that compose the image. And here is the range of pixel values for this band. In order to use these images for certain image analysis functions, the pixel values need to be scaled to the range of 0 to 1. So these are the values that need to be scaled from 0 to 1. As described in the Landsat documentation, the application of a scale factor and additive offset converts pixel integer values to decimal values between 0 and 1. This is equivalent to the range of 0% to 100% of the reflected light for a particular pixel and wavelength. The scale factor and additive offset are applied to each band using the raster calculator, with all of these scaled images going into the associated QGIS group and folder. After scaling, all of the pixel values for all of these spectral bands should fall between 0 and 1, but the minimum value for this band, for example, is less than 0. So why is this? Back on the Landsat documentation, we see valid raw data ranges for pixel values. Values outside of this range are from pixel measurements that are in some way corrupted. For the example of band 5, we see that there are some pixels with invalid values, so these must be corrected in the scaled images. So what we need to do now is compensate for the invalid pixel values. We do this using the raster calculator to create corrected versions of each image. Here, we set all the pixel values below 0 to the minimum valid value of 0. Note that a similar operation would be required if a scale value exceeded a value of 1, which can be corrected to a value of 1. This last set of processed images should go into the appropriate folder. So we are now done processing images for the remaining tutorials in this series. So what can we do with these images? In the next tutorial, we will use the corrected images to calculate various vegetation indices in pursuit of the overall goal of this series of tutorials, which is to monitor vegetation extent and condition. So that's it for this tutorial. Hope you will enjoy the next tutorial in this series. Please note that this series of tutorials would not have been possible without the generous assistance of staff at the USGS Earth Resources Observation and Science Center. If you have questions on how to use Landsat data, contact their customer service. All Landsat data used here courtesy of the U.S. Geological Survey. Thanks for watching this video. See the description below for links to all of the tutorials in this series.